Well, hello and welcome. In this video, I'm going to describe the basics of unit conversions, which is another way of describing a situation where you're asked for the answer to a problem to be in a certain unit. For example, maybe it's a metric unit. They want meters or they want kilograms, but what you have is perhaps an English unit, a little less convenient, like inches, feet, yards, miles, things like that, or maybe pounds. So there's a process doing unit conversions. Of course, you could Google it. Google will convert anything, but to be able to do it by hand, I can think like one best way to do it. And I know at our school, chemistry teachers call it different things, but we're all basically doing the same thing. Let's see if I can get this focused here. Sorry. That's better. So what I'm going to imagine is each time we have an answer or we have a number that we want to convert to a different unit. And I'll start with the simplest one. I'm going to do 4 of them and work my way to the more complex. If you want to skip through or do the first part at a higher speed, I totally understand that. But I am going to describe the basics in this first one. So I'll just use the number 50 each time because it's convenient. So maybe we're given 50 kilometers. We figure out something's 50 kilometers, but we want to know what it is in meters. Many times in physics, we want things reduced to either meters, kilograms, seconds, or some unit that's a combination of those. We call that the MKS units. So 50 kilometers changed into, now, of course, it has to be an equivalent type of unit. You can't change kilometers into pounds, or you can't change minutes into feet. If you're measuring a length, you've got to have a length unit. That should be fundamental. So what I'm going to do is I'm going to set the problem up, kind of setting myself up so that I have room to do the work. And so like my answer is going to be here at the end equal to a certain number of meters. And what I'm going to show you how to do is fill in the rest of this here. So what we do is we turn this into a multiplication problem. Sorry about the focus. It'll get back in its spot here. So we set up a multiplication problem where we multiply this original number by a series of fractions that are equivalent to 1. Because multiplying by 1 won't change the value of something, but I'll show you how it can change the units. So in this situation, we're just going to need to multiply by a single fraction. And here's why. As long as you know how many of one of these is equivalent to how many of one of those, you can do the problem with one of these factors. Okay, we call this a conversion factor. And so what I recommend is you set up the problem with the units first and then put in the numbers. So here's how you set up the units. If you have kilometers, like here, it's with the number. I would say that's in the numerator of a fraction, but we don't write this number as a fraction. The number 50, most people wouldn't write 50 over 1. But we can understand that in any number, there is an understood denominator that's equivalent to 1. You could even write it in there if you wanted to. I'm going to write it very lightly. But that helps keep track of things top and bottom. So what we want to do is get rid of the kilometers here in the numerator, and we want to end up with meters in its place. So what we do is we put the kilometers in our conversion factor in the location that will cancel it out with this one. And you have to remember multiplication of fractions, things on the top and bottom will cancel out. So if we have it on top here, we're going to put it on the bottom here. And then what we're going to convert it into goes on the other side of the little fraction line. So that's how we set up the units. And then you just have to know how many meters does it take to make a kilometer, or alternatively, how many kilometers are in a meter. I always like to say how many of the little things make the big thing. It's just easier for me to picture. You do need to know, at least in my class, the metric prefixes in their meaning. So kilo means 1,000. So writing 1 kilometer is equivalent to writing 1,000 meters. So I'm just going to put the number in place of the K. So you see, this is 1,000 meters, and this is also 1,000 meters, just written different ways. Okay? So what I also might recommend is either on paper or just in your head, imagine canceling out those 2 kilometers. And so you're left with just a unit of meters, which is great. That's what we want. And then you grab your calculator if necessary, although I don't think you'll need it here. And everything on the top you multiply, anything on the bottom you divide. So the numbers here would be 50 times 1,000 divided by 1, which is just going to be 50,000. So our answer, and again, I'm choosing a really easy one just to show you that it comes out to what you probably already knew. If you knew 50 kilometers and you knew that there were 1,000 meters in a kilometer, a lot of people in your head could figure this out. But this is what it looks like in a more formal, kind of lengthier approach. But what if it's something where you don't know the conversion off the top of your head? Let me show you that. So maybe it's 50 inches, and we want to know what that is in meters. So you could look up the conversion from inches to meters, but that's not likely that you'll know that. But perhaps you know some other more familiar units, like for some reason I remember, because I grew up at a time where America was trying to switch over to the metric system, so we tended to remember that 2.54 centimeters was an inch. So I'm going to use a little trick where I'm going to use two conversion factors, both of which I know off the top of my head, and it doesn't matter how many times we multiply by 1, we're still going to get something equivalent. So watch this little trick. I'm going to put the units in first to switch the inches to centimeters in one step. Boy, my camera's having a hard time waking up. I apologize. Maybe zooming in might help. Okay, that might help. So inches to centimeters, and then centimeters to meters is another conversion you should know off the top of your head because that's a metric prefix. 100 of the little centimeters makes a meter. So I'm going to put the centimeters down here and the meters up here. Now again, be careful for where you put your units. I'm not just choosing any old place. Inches on top can only cancel inches on the bottom. Centimeters on top will cancel these centimeters on the bottom, leaving me only with meters that's uncanceled. And that's exactly what I want in my answer. So I can do all of this without even putting a number in. So again, I happen to know from my experience that 2.54 centimeters is equivalent to an inch, and 100 centimeters is equivalent to 1 meter. And so this one I'm not going to do in my head. I'm going to grab my calculator, multiply. I'm going to do this all in one step. So here's a little bonus tip for you. Don't try to do these problems with parentheses. You don't need them when you're multiplying and dividing. So watch my sequence here. I multiply everything in the numerator first, and then I just hit divide by, and anything I have on the bottom I hit divide by. Okay, so this will look like this. 50 times 2.54 times 1, and yes, I know I don't really need a times 1 in there, divided by 1 and divided by 100. See, no parentheses in there. Everything on the top multiplied, everything on the bottom gets led by a division sign, and I get 1.27. 1.27 meters. I am not being real careful with my significant digits. That's a whole nother conversation. I'm just going to say that's my answer. Okay. If you're familiar with a meter stick, you might know about 40 centimeters is a meter stick. So it makes sense that a little over a meter stick would be 50 inches. Oh, I said that wrong. Sorry. I think I said centimeters. 1 meter stick is about 40 inches. So 50 inches would be a little bit more than that. Okay. Let's talk about fractional units, because that's not unusual at all in physics. Maybe we have 50 kilometers per minute. And I'm going to recommend you write your fractional units like this, top and bottom. Not with the slash and then put the minutes next to it, because it sort of hides the fractional feature of this. I want you to clearly see top and bottom, because it makes the whole top and bottom conversation easier. So now, if you know conversions between kilometers and meters and between minutes and seconds, we could convert this to meters per second. This is a speed unit, how fast something is moving, kilometers per minute. That's a pretty fast kind of a thing. I mean, a car could certainly go on the order of kilometers per minute. But what we do here with fractional units, treat it as two separate steps, not one unit, but two. Kilometers in the numerator, and separately minutes in the denominator. Each one is going to be converted by its own conversion factor. Again, just straight up multiplication here. Set up the units ahead of time. Notice I want to get rid of kilometers that's on the top, so I put it on the bottom. And I want to turn it into meters on top, so I'll put that there. I want to get rid of minutes, which is on the bottom. So I'm going to put it on the top. I see people make that mistake a lot. They'll just automatically put whatever unit they see here on the bottom of their conversion factor, and that's not appropriate if it starts on the bottom. But I can convert minutes into seconds. And then again, just canceling. I'm doing it visually so you can see this canceling. Minutes and minutes. Now look what's left. Meters hasn't been canceled and seconds on the bottom hasn't been canceled. That's how we're going to get meters per second. Now let's pick the numbers that make sense. How many meters makes a kilometer? It's the same one we used up here. It's 1,000 meters, makes 1 kilometer. How many seconds makes a minute? On all the clocks I ever use, it's 60 seconds to make 1 minute. And then we grab the calculator. I'm going to multiply all the numbers on the top. So this is 50 times 1,000 times 1. And then I start hitting divide. Anything on the bottom, you hit divide. I don't have a number over here under the 50. I suppose you could think of that as a 1, but you don't really need the ones anyway. So I'm going to divide by this 1, and I'm going to divide by this 60. Again, no parentheses in sight anywhere. I hit enter, and I get 833. And that's the equivalent speed in meters per second to 50 kilometers per hour. So I told you, that's pretty fast, 833 meters per second. Typical car might go 20, 25. All right, the last thing you might encounter. What if your units have squares and cubes on them? And they often will in physics. They could even in other subjects like chemistry. So let's just make one little change here. Suppose instead of kilometers per minute, it's kilometers per minute squared. Now, if you're not familiar with acceleration units, this might be like a big mystery. What are you talking about? How do you square a minute? You're picturing like a shape of a square or something. Let's just not worry about that. Just this happens sometimes. Maybe it's a volume, for example, and you have meters cubed. That's a volume measurement. So this could happen in more familiar terms. Everything about this conversion is the same as the one above it, except for one little step. We're going to change this into meters per second squared. That's a distance unit divided by a time unit squared. I'm still going to use these two conversion factors. And in fact, those conversion factors will be almost identical. I'll show you when we make the little switch. So I can change kilometers to meters the same way I did here. Meters on top, kilometers on the bottom. And I know that 1,000 meters is equivalent to 1 kilometer. So that part, no different than above. I'm going to set up the same conversion factor for minutes to seconds that I used up here. And I know that's not my unit. But we're going to still use the same one. And then here's the big difference. When your unit is squared, you just go over to the conversion that you're using to convert it, and you square both numbers and both units. I didn't leave myself a lot of space here. So it's a bit of a mouthful to say this, but it would be correct to say 1 squared minute squared is equivalent to 60 squared seconds squared. Told you it was a mouthful. Now, on the calculator, the only difference is when you hit anything with a squared on it, you just hit the square button on your calculator right after that. So here's how this would look. Make sure you can see this on the screen. 50 times 1,000 times 1 squared. There's my little squared. Divided by 1. Notice I'm not putting squares on anything except where you see my black ink on these two numbers. And then this right here, squared. That is what's going to make a difference between what we got in this third example versus this example here. And this is going to be a little bit smaller. And it is 13.9, we'll call it. Again, ignoring sig figs. I know that should probably be more like 14, but that is the equivalent acceleration to 50 kilometers per minute squared. Okay, so a couple key tricks. 1 unit at a time, not the whole chunk at once. Make sure you place your units where they can be canceled and do that part before you put the numbers in. use more than one conversion if you don't know the equivalence between two things. You have to, of course, you have to know the equivalence between something, otherwise you can't do this conversion. And then when you have squares, cubes, or higher powers, you just put those same powers inside the conversion factor that goes with that unit. So we put it here on this time one, but we didn't put it over here on the distance one. All right, so I think that's probably more than you needed to know about conversions, but hopefully you've seen just about everything in here that you would see in a typical physics class. Okay, thanks for watching. Hope that was helpful.